Structure and Interpretation of Computer Programs, SICP, by Harold Abelson and Gerald J. Sussman is a seminal textbook used to teach the fundamentals of computer science and programming. The book focuses on how to think about computation and structured programs effectively, using the Lisp dialect, scheme, as the primary language. Here's a summary of the key themes and concepts. 1. Abstraction and modularization. Abstraction is at the core of the book, helping students understand how to break complex problems into smaller, more manageable components. Procedural abstraction and data abstraction are introduced as ways to structure programs so that details can be hidden and code reuse is maximized. 2. Programming paradigms. Functional programming is heavily emphasized, with scheme used to demonstrate how functions, procedures, can be first-class citizens and operate on other functions or even return new functions. Recursion is introduced as a powerful tool for problem solving, and the authors explore both simple and complex recursive procedures. 3. Metalinguistic abstraction. SICP goes deep into the idea that a program can create new languages, often referred to as language-oriented programming. It covers how to design interpreters and compilers, giving students the tools to create their own programming languages. 4. State and effects. The book explores how mutable state, variables that change over time, impacts programming, and how side effects and stateful programs differ from functional programs. Concepts such as environment models, closures, and stateful objects are covered to explain the relationships between procedures, data, and memory. 5. Streams and lazy evaluation. Streams are used to represent sequences of data that are potentially infinite, allowing for computation on demand, lazy evaluation. This concept helps students deal with large data structures and continuous data flows in a resource-efficient way. 6. Computational processes. SICP emphasizes thinking about programs as models of computation. It categorizes processes into iterative, recursive, and stream-based forms, helping learners understand how computation unfolds over time. The book discusses time and space complexity, teaching how different program structures impact the performance of algorithms. 7. Building interpreters. One of the highlights of SICP is a chapter that teaches how to build an interpreter for a simple programming language, emphasizing the flexibility and power of language design. This exercise solidifies the idea that language and tools can be shaped by the programmer to solve specific problems efficiently. Why it's important. Conceptual depth. It doesn't just teach syntax or programming tricks. It builds a foundation of understanding in how programming languages work and how to think about computational processes. Influential in education, SICP has been used for decades in university-level computer science programs, particularly at MIT, and has shaped the way many people approach programming and computer science. Overall, SICP teaches you to think like a computer scientist, focusing on the essential principles of programming that transcend any single language. It's a book about understanding computation from a deep, conceptual perspective, using scheme to illustrate its ideas.